All right. Good morning. Welcome to Jaxx Vane Studio Live number 14. We're live 3 times a week on Twitch. Today, what's the situation today? So, you remember that I had a difficult day with physics on Wednesday. Then on Friday, I concentrated on something else. Then Friday evening and Saturday, especially Saturday morning, was a sort of revelation day. And I went and I adjusted and found balance, reading. So what the situation is right now is I have a boat that is quite difficult to drive. I have some new indication in the HUD where you can see where basically I have the controls, and this is my input for the helm. This is my input for the sail trim control, and this is the input for my foils, right? Now, what's interesting is how much I really didn't pay attention to how important the sail trimming was. So if we start, as usual, we get to 90 degrees from the wind. So if we try to foil, you will start to see that foiling in this configuration basically means finding an equilibrium between all the controls. So the helm, the foils, okay, we're up now on the foils, and especially the wing trimming. As you can see, maybe I hope you can notice I'm changing the trimming on the wing, and you see that the boat is reacting with the roll, right? So that's essential. That's really essential. So as I'm getting power from the wing, remember that when I say wing, you know, it's called wing because it's a wing, but it's a sail on a traditional boat. As I'm getting power, let's see if I can stop it. So try to explain you what's going on. Let me get my forces up. Right, so this is the force that I'm getting from the wing, right? So what is happening is that as I am powering the wing trim, so this is pushing the boat this way, so the boat is also rolling. So it's an amazing balance between these really two elements. It's like the foiling, so the angle of attack of the foils, and how much wing power I'm getting from the wind that is trying to roll the boat, right? So driving this thing in this configuration, it's really, this is probably like, you know, I would call it like the most hardcore, where a single player is trying to do the job that on the real boat is something that is the job of 3 people. So I'm sure that eventually I will get good at this. Or something else, right here, we have the ride height from the boat. So this is telling us that we are riding at a good height. So to recap, this is the ride height. This is my helm control. This is my foil control. This is my sail trimming control. Right. So you see that I'm trying to find a balance, right? And on the top of this, which is something that I still don't have in the new HUD, I also have my rudder differential control, which is also super important to because again, let me stop this. What we want ideally is to get as much power as we can from the wing that is going to try to roll our boat that way, and we can resist that motion with our rudders. And if you remember the rudder differential, which is going to act on these foils here. So if we can see now that, for example, these foils, we have right now no rudder differential. What is happening is that this foil is pointing down. That's, you know, is trying to push us down. This foil is trying to push us up. It's just a result of the fact that the boat is rolling. I can change these angles, so they would sort of do like this, right? So what we want is this guy. You cannot see me pointing. What we want is really this guy to push down a little bit, and this guy to push up a little bit. So we are resisting the roll of the boat, right? So the wind is trying to push us this way, and we want to resist it like this. Remember that although this works, you really, ideally, you want to run these things as close as possible to zero angle of attack, because you want as less drag as possible on this. This is the situation right now. So it's definitely something difficult, but it's playable, and it's really satisfying once you really get it right and you dial in, right? And we're going super fast now. We're going 41 knots, right? And it's a constant motion up and down. It's very exciting. Sometimes you drop it, it goes in the water. It's super cool. But the interesting element is that I'm also starting to see elements of simplification of this. So, for example, I can forget about the sail trim control. So now the roll control on the sail power will be handled by the computer. So right now, so to recap, this one you will see movie, but it's basically the computer doing it, right? I still have control over it. I can still tell the computer to change the amount of power that I want. Again, this could be very important for starting, right? But you will see this moving down, especially, and this is going to be the computer doing this. But I will still have control on the foils, and I still have control on the helm. So let's see how this feels like. So this is going to be already way more relaxing. So let's get up to speed. At around 12 something, I can start to moves. Okay, so now we're flying, and look how straight the boat is, right? And this is all thanks to the automatic control of the sail. So I'm still able to, I'm on the water now, yeah. I'm still able to move up and move down. So I still have to control that part. But the boat is mostly staying level. You still need to be careful, especially when you want to change direction. If now I'm going to turn left and the nose is going to come up, right? So I need to be ready for that and put it down, right? And the opposite is happening when I do this. So I want to pull up a little bit, you know, just to keep the boat level. So this is, I have a feeling this could be, I really hope this could be the mode that most people will use, right? And then I can go really simple, and I can even have the foils controlled automatically by the computer. And this makes it really, SDR Media, thank you very much for the follow. So, and this makes it really super basic. So right now I am just deciding how much power I want, but I get an automatic trimming for the roll. I'm not controlling the foils anymore. I do this, nothing happened because it's the computer handling it. I'm only basically pushing this and turning left and right. Of course, the code is super simple, so I'm sure that there will be situations where I could do something to really put the computer in a bad situation. But as you can see, now we're flying. Power is pretty much automatic. All I have to do is to steer the boat, and we are super stable. Right, and this is so easy that I can literally put the camera in every position that I want. You might have seen this, some shots taken like this. Right, it's really super stable. It's really that easy to control. So great progress on this. 30 knots. And then I'll slam it into the water and see how cool it is. Bang! Right? And it stops pretty much straight away. We went from 30 knots to 7 knots. So that's super cool. And this is basically what happens if you lose. Right. So right now we have this guy is up. It's not in the water. So that's the typical configuration when going this way. So the wind is coming from this side, so the boat is going that way, and all the weight of the boat is on this guy. If I want to, so I'm fine sailing in all this half quadrant, right? If I want to go on the other side, I will have to invert this. So this foil will have to go up, this foil will have to go down, and we can change direction and go on the other side, which is something right now that the system cannot. I should see immediately something super weird on the dagger-boards in the front. They should be in a completely different position. Let's see where they are. Okay, so they end up down there, which is exactly what I was expecting, right? The reason is that they are now attached to another group, right? So they are attached to somewhere around here, and they are adding their own offset to this. I was playing a little bit yesterday with Unreal because I will have to help a friend with a prototype, and I was able to have the boat on the sea in like literally 5 minutes. And when my wife saw it, she was like, why are we not using Unreal again? It was pretty difficult for me to explain to her. And I go, look at this. It took me literally 5 minutes. And it looks already better than what I have. But hey, that's no fun, right? Now, what I hated was really working with a real engine and C++. That was painful beyond any imagination. It was really painful. In fact, my plan, I have to help this friend do a prototype in the next couple of months. And my plan is actually try to do everything with a blueprint this time, just to see what's what. I never really tried to use blueprint for anything seriously. I don't know if he is going to allow me to stream some of the development of his prototype. It looks amazing. The graphic is amazing. And my God, 24 hours. I'm really not young enough to do that. Too old. All right, that looks like it's a good position for this guy, and I think I can be happy with this for now. For now, I can be happy for what I'm trying to do today. So the idea is that, so right now, this thing should, the good news is that this thing should sail. Let me raise this guy a little bit more. The only jam I do is on the guitar. Yeah, that's true. Yeah, I really enjoy watching Tim. He's so cool, and he's got the parrots and everything, and the animals and everything. All right, let me see if I broke something. In theory, it should just work. Let me enable this. But it looks like I see the forces in the right places. I might have lost a little bit of lift because I have the dagger-boards, but I'm still able to fly, so that's good. Now we want to be able to move these guys, right? So let's start brutally. Let's start essential for this game argument. But would you say that conversely, if time to market is important for someone, they should use an existing engine? Yeah, I think so. It's definitely a better use of resources. It also comes down to, as usual, the answer is really it depends, because it really depends on what the kind of game you're trying to do and what kind of skills you have. Because if you already have experience in writing an engine or have some code that pretty much already does what you need for your game, then the difference between using an engine or custom code becomes smaller, right? If you're doing a 2D game where all you have is sprites and sprites animations, then yeah, there isn't really much of an advantage in using an engine, as long you have an experience that will allow to have your engine up and running in a stage where you can start prototyping, I don't know, in a couple of months, right? If you're trying to do something that compete with a real engine when it comes to rendering, then yeah, then you're wasting time if you're trying to write it yourself. Yeah, the coding part doesn't scare me, but I think I need something to speed up level editing and the rendering pipeline and cross-platform porting. So I've been started to use Godot. Yeah, I mean, I didn't touch on the cross-platform, which it's a huge part of choosing an engine. If cross-platform for you is important, then again, you are cutting a lot of development time with a third-party engine. In my case, cross-platform is, I don't care. It's gonna be Windows. I don't care about the rest. I don't care about consoles. I don't care about Linux or Mac. So it's gonna be Windows. So for me, the cross-platform is just not an element in my decision. All right, so that's what we have at the moment. So we have both dagger-boards up, right? I wonder how this will translate into boat behavior. I would imagine we will be bouncing over the water. Let's see. Yeah, that's it. We're pitching up. Yeah, and that's the amount of pitch up that we can do. That's it. Let me turn off the. Okay, that does exactly what I expect. Okay, so that's exactly what I expect now. I need the commands to put the boards up and down, right? So rise to the engine. I can only begin to imagine the amount of banging heads on the desk it took to get the physics working well in engine. Well, actually, the physics was the easiest task, because the Assetto Corsa 1 engine, physics engine, was already pretty much designed to be completely independent from the graphics and the rest of the game. So it was pretty, I mean, we had the car running in competizione in a real engine within the first week, probably. It was really easy. It was really easy. What was difficult was to deal with the Unreal Engine, understanding how Unreal Engine worked on the game side, and as the project proceeded, dealing with the friction of the entire compile time and so on. But the physics was the easiest part. And what was really difficult was to work with it day after day. Like, especially things like artificial intelligence for me was a nightmare, because as you can see in this stream, the way I program is really change very little and then run and confirm that I'm going in the right direction, right? And imagine trying to do this with 1 minute and a half every time you want to change something and press run, and it will take 1 minute and a half for the thing to go back to where you were. It really didn't match the way I programmed for too long. Yeah, it's like I have a sort of idea of where I'm going, and I'm just constantly checking that it's the right idea. Usually it's something that you never see on the stream, because on the stream I'm always doing new things. But usually what I do is like 3 steps. It's like make it work. So I try to make it work in a way that the code is reasonable, but I'm really concentrating to make it work. And then once that is done, I will clean it up and make sure that the code make more sense, because I will have at that point I will have a better understanding of how everything works. And then the third step, which is something we haven't done here yet, is to make it fast, which is usually it also means that you start with a code that is sort of clean, and then it's not clean anymore because you're trying to squeeze performance out of it. So sometimes, yeah, that cleanliness goes away because you're trying to do things pinpointing the performance. So theory now, I should be able to move these boards up and down. On the physics, so we still don't have the graphics attached, so we still won't see anything happening in the graphics, but we should see these things moving. So let's see, X for the left, boom, and it goes down. That's beautiful. And right, and left, and left, and language is Rust. That's all right. That works, and I think we should be able to sail this thing on the other side for the first time, right? So all I have to do is drop my left board, turn finally on this side, and go. Let's see. I haven't been sailing on this side for weeks. Go up, baby. Oh, interesting. It's behaving completely differently. Do I have the... Oh, this is... I don't like what I see. board down. Ah, I know why it was different. Hold on. I know. I need to move on this side. Because the weight was on the wrong side of the boat. This is awesome. Why are you not rotating? Come on. I'm stuck. Come on. Okay, let's try again from this side. So left board down, right board up. I need something to tell me. Okay, this is down. Okay, let's go. Well, the most important is not really the view, is the weight, because when I am in this view, the weight of the crew is on this side of the boat. All right, so let's fly. Okay, I think I need to fix this correction. All right, that's much better. Still not flying. Still not flying. We're still in the water. Jibe. Attacking jibe. Yeah, but when we go on the left, there is something that the things doesn't understand. It's either the trimmer or I don't know what it is. You tend to write what in C++ you're sort of forced, and in D and in C#, you're sort of forced to have this kind of, a vector of people pointers, right? Or unique pointers, shared pointers, whatever you want. But it's basically a pointer. So if you want to go through this collection and you want to do stuff with those objects, you have to go through 2 pointers, right? So you have the pointers of the data inside of vector, then you get the pointer to people, and then you jump to people. And potentially, all these objects could be in separate part of the memory, right? Of course, the problem is that, hello, Zucooker, thank you very much for the follow. The problem is that you could do this, but then what is happening is that as soon you do, so if you do, right, in C++ and you do people's pushback, right, potentially all your stuff that was here, potentially it gets a destructor called, right? So if you're wrapping a texture, that texture is gone, right? And that's not what you want. You can avoid this in C++ 11 with the move constructor and move, what's the other thing? Assignment operator. So you can create in C++ value classes that behave like this. So they actually get destroyed when they get out from the vector. But it's still difficult to track all these things in C++, while in Rust, it just does it automatically. And that's probably my main attraction with Rust. So in Rust, you can still have a pointer. They're called box, right? So if I want to do what in C++ I do with, if I have a float pointer A, in C++ I do new float like this, right? In Rust, I will write it like this. So A becomes a box new one, right? So that's a pointer to a float, right? And the cool thing is that this entire, and if I look in my code, right, for this, so if I'm looking in my code for pointers, I get skybox. If I look for box new, right, that's the only thing that I have, right? I have this, which is an interface with the C#, and I have this one, which is the level, and I need this to be a pointer because it needs to be polymorphic, and I am forced to create a pointer. So that means that in my entire, this is like writing a program in C++ where in my entire sailing program, I use new one time in my code. Of course, every time you see a vector or an hash map or whatever, of course, inside is creating memory, right? But you don't see that. But me, I'm not using pointers anywhere. It's all flat memory, super fast to go through, and so on. It rolls more. It rolls more. Which forces my sail power trimmer to do the right thing, which is reducing power. The question is, why is not doing it on this side? I'm doing it, so it's 0. Hold on. I didn't have the boards down. I'm such a moron. Let me put this back. Okay, come on, fly. Fly, baby. No, it's reducing power. It's reducing power. Why are you reducing power? Yeah. So this side we're flying. It's difficult because I'm used to look at the foil to understand where I am. I have to look at the indicator because the Jaxx, say something. Say something live on Twitch. Say. I'm also slower on this side. It's like it's using less power or something. Quite exciting to be able to jibe like that. How fast we're going here? We're going already 30. So there is still something. There is still. I don't get it. I don't get it. I don't get it. I must have something wrong, different left and right here. That's the only explanation I have. Could be the rudder that is different. It is all the same. Doesn't really go. But while on the left, it's rolling a lot. It's rolling a lot. Am I changing the... Should I turn off the weight shift? Is there a problem with the weight shift? Crew position. Did I change? Hold on. I think I know what's going on. Because I changed the control to change the camera left and right, but the weight doesn't go with the camera, is it? Yeah, it's still D-pad left and D-pad. Okay, that's what it is. So instead should be left thumb and right thumb. That's what it is. So basically, what was happening is that even though the camera was moving in that place, the actual weight on the physics was not moving. So it was like the crew was remaining on the left side. And let's see how it works. It's if it is like this, it's amazing. It's amazing because it's really forcing you to have your point of view in the right place. Here we go. Come on. And we're flying. Yes, 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 yes. That's exactly what it was. Let's try a tack. Tack is going to be even more difficult, but let me do the graphics first. Let me do the graphics because otherwise it's going to be difficult to appreciate. All right, so the graphics. So the boat, okay, first thing I will need to communicate this one. All right, that's it. This should automatically, sort of automatically work. I have, okay, if it's working on the wrong side, on the wrong way. Let me see. All right. Because we are dropping more than that, right? Yeah, that's good to me. That's good. That's good. All right, so we want to go all the way on the left. So first, let's move to around 135. We have the boat moving up and down like crazy. Okay. We're a little bit in the water. See if I can complete my first 360. All right. So that way. So what we do? So if I need to change the control, so board down. All right, board. Oh, woo, woo. As soon the board comes down, I get tons of lift. Okay. We jibe, we jibe, we jibe. Okay, we go on the other side. All right, put this board up. So complicated. Sway. Okay. Let's go up 45 degrees, something like that. Okay, now the difficult part, back. So, board down. Turn. Turn, 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 turn. This way, bang. All right, that was a sucky. That was a sucky tack, but I managed to do it because it's impossible for me to. Just to explain, because I'm steering with this and foiling with this. When I need to drop the boards with these keys, I need to move my finger off. Thank you, MRZ, for the follow. I need to take my finger off my foiling, and that, makes my boat goes like this every time I try to change. So the idea is I put everything on here. So steer left and right and foil up and down. And hopefully, okay. So now we're foiling this way. And I should be able to drop, control it. I'm in the water. Tack, boom. Okay, other side, board up. And sadly, I'm not flying. It's difficult. It's difficult. It's super cool, but it's difficult. It's really difficult. All right. We're foiling now. So let me hit that one. So I'll go there and then try to tack again. Okay, so ready to track. Board down. Turn, 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 turn. Oh, turn, turn. Okay, boat in the water, go on the other side. And this up. That was that was all right. I really want a replay. I really want a replay function. I would really like to see this from outside. Let me give myself a little bit more wind. So we're falling straight away. This one. Right. So what we want to do. So board down. Boom. Control it. Turn. 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 Ooh. Turn. Other side. Board up. Come on, come on. On the points. On the points. On the points before. Let me do this bigger. Here we go. Oh, yeah, associator. Let me try to do this and then I will read your question. I just saw your name. Bang. Turn, 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 turn. Other side. Board up. Oh! Okay, that was slightly better. I touched the water a couple of times, but it was better. And we're falling. All right, this is cool. It's very difficult, which I like that it's difficult. I like that it's difficult because it's adding a lot of abilities in the game. Allowing the typical problem that you get in object-oriented games, at least the games that I've done up to a couple of years ago, where you have a class car, or let's say like a class tire, and in that tire there will be a pointer to car. So the reason why you do that is because you want to call update on the tire just passing a delta t, and you want the tire to do all the updates by itself, right? By magic. But what you don't see is the fact that tire now has a lot of dependencies that when you call update are not obvious. You don't know that tire is going into the car and maybe changing stuff into the car, right? And so the dependency graph becomes out of control. The scope, because you tend to do this thing over and over again. You tend to have a small things that has a pointer to the bigger things, that has a pointer to the big thing, that has a pointer to the god class. And the result is that you call update on something, and that thing potentially can go out and change everything in your game, and you have absolutely no control over that, right? So I love how in F# doing this is close to be possible. In Rust is very difficult. It's very difficult to do it. In fact, if you check, for example, a sail structure, there is nothing inside the structure referencing back to a boat, right? There is nothing. There is nothing in here that suggests that in order for this thing to work, you will need a boat. Of course, at a certain point, like for example in the foil, right? In the foil, same thing, same stuff, right? There is nothing that goes out from this. It's all from the foil down. There is nothing going up, right? Of course, there are situations like this where in order to get this final matrix, I need to have the matrix of the foil groups. But these are given to me from outside. So when I look at this function, I know that there is nothing in here that can, when I look this function called from outside, so if I it's not this one, when I call this, all I know is that, right, this function is doing things with this data structure, is not even changing it because it's getting a self, so it's immutable, it's not changing anything in my foil, it needs, in order for it to work, it needs these foil groups, is reading the stuff, giving me a result, and that's it. And that's it. There is no way for this thing to go out and change stuff in the world. If this was my old code in C++, this will look like, this will look like in C++, this will look like update. Right? It will look like this without all this code. So you will look at it and you will think, oh, that's a very elegant way to write code. The problem is that you have no idea what's going on inside here. No idea. You have no idea of what are the connection between foil and the rest of the world, because usually these connections will be set up when you create the foil, right? Which will be in a completely different part of the code. So you will have absolutely no idea what's going to happen in that function. It looks elegant because it gives you this object-oriented illusion that foil is an independent entity that can do stuff by itself. It can update itself and create side effects to other things like the boat, right? So it looks elegant, but then it's very easy to get this stuff out of control. And Rust and F# makes this kind of stuff very annoying to implement. So it's like, it's sort of pushing you, don't do it, don't do it. We're able to go around. I like how difficult it is. It's really tough. It's really difficult. Let me just try one time with the automatic foiling, just to see how, if it becomes trivial, broken. All right, okay, so let me see how easy this becomes. So now I am with auto foiling on. Let's see. So I'm basically just steering left and right. All right, we're falling. Whoa. Get a bit of speed. Board down. Turn. But it's super easy. Other side, board up. This is super easy. Look at this thing go. All right, stand by. Boom. Turn. Boom. Other side. Wow. This is super easy. I wish there was something in the middle. I wish there was something in the middle between this easy and relaxing, and way more complicated if you need to control the pitch of the boat. But it's cool that we have something that is pretty easy. So if you just want to go for a a very fast race. If you think about it, if you're sailing, well, it doesn't have to be like this, right? You can still turn off, for example, the trimmer, the automatic trimmer, right? And trim the sail yourself. So you don't foil, but you trim. So you steer and you trim. Potentially, you could also leave the steering to the eye and you're just flying, or you're just trimming, which could be a good exercise for, I don't know, training for multi-crew. Oh, this is interesting. Hold on. Maybe I found the bug. I think I found the bug. Well, a bug. I can't turn this. I can't. All right. I need, because I need a board. Okay. That was better. All right. I don't think it's possible to not to control at least the board. At least you need to be aware that, okay, I'm going to change direction, drop the board, turn, go here, up the board, right? That you will have to do it. Oh my God, we're going super fast now. 46 knots. Bang. Turn. Oh, that's awesome. This side, burn. Wow. That's awesome. All right, okay, so it's nice to, I think, to close the stream on a positive note. How is my, so we dropped the dagger board, we did the 360 degrees. So my left thing, the thing that is left me to do these days is to have these lap times so I can drive the boat and trying to be competitive, start to have an idea of how long it takes me to do a course back and forth, upwind, downwind, and see how it goes maybe with different settings. But this looks really good, really promising. I'm really happy of the progress, and that's cool. That's cool. Well, guys, thank you very much for all the people that watch this with me. I will be online next time, Wednesday. Remember, Wednesday I changed my time, so it's not going to be 6 p.m. It's going to be 10 in the morning like today, because it's. I will see you guys next time. Ciao.